Welcome back to this part 4 video. Math is easy, take step by step. We're solving a GED test word problem. We've determined at this point in part 4 video that we will be using Pythagorean's theorem or Pythagorean's theorem. A squared plus b squared equals c squared. So right now we're reviewing key knowledge, skills, abilities that you must have prerequisite knowledge in order to solve this type of problem. So let's continue our review. Right? I want to show you manually, and I also show you using a calculator how to simplify radicals. Radicals or simplifying square roots, right? We call them radicals, we call them square roots, whatever you prefer, right? And that is the inverse, right? Square roots or radicals is the inverse operation to simplifying a square, right? 10 squared or 6 squared or 12 squared, which I just reviewed in that last part 3 video. And so let's just get down on to it and do it. Okay, so again, square roots or square root is the inverse operation to square values, right? And so in this example number 1, we've got plus or minus the square root of 100. All right, there's something I want to explain about this value here of the radical or square root. It's kind of like my invisible ones that I teach. Okay, so in this square root, typically they're not going to show you the 2. They just give you the square root all by itself, and they say, hey, you're supposed to know this is a square root. But if you have a cubed root, that would be a 3 right here. If you have to the 4th root, there'd be a 4 right there, or 5, and on and on and on. It's shown. So I don't quite understand why they don't show it. Usually I'm working with invisible ones. This is an invisible 2. So this is a square root. And the 2 would belong right there. So I want to show that in order to clarify. Okay, I don't skip steps, and I'm teaching this, so I want to make sure I'm teaching this correctly. So could I do this? Could I write a solid 2 right in here with this square root value? Absolutely, you can't. And I'm going to show you in just a little bit when I use my calculator. The function on our calculator has that value of 2 on the function you need to select on your calculator. So I just wanted to clarify. Also, every square root, cubed root, let me back up. The square root, every square root has a plus or minus, right? Every one. Now, working with triangles, which is a measurement in length, there will never ever be a negative value in a length. But every square root you have here that we'll be working with has a plus or minus value. I'm going to get into that and explain that a little bit later on. But again, we're working with a right triangle with 3 leg values. One's a hypotenuse, leg A, and leg B. And when you're measuring triangles, you'll never ever have a negative value. But these square roots have a plus and minus right out in front of them. I need to clarify that before moving on and doing anything further. All right, so again, when you're working, and I wanted you to see this, working with triangles and geometric shapes, there are only positive values, right? And so that needs to be understood. But every square root, again, has that plus and minus in front. I'm going to go over that in detail a little bit later on. So our target here is 100, square root of 100. So I'm going to take 100 over here. I'm going to use what I'm calling is a factor tree. It's kind of like reverse factor tree. But I'm going to take the value of 100. And I want to divide the smallest number that goes into 100 other than 1. And I'll start with 2. If 2 doesn't work, I'll try 3. If 3 doesn't work, I'll try 4. If 4 doesn't work, I'll try 5. On and on and on and on. So I know 2 goes into 10, right? 5 times. That's the 5 right here. And I know 2 times 0 would get me that 0 right here, right? So 50 times 2 gets me 100. Okay? So if I divided 2 into 100, I would get 50. I know 2 times 50 is 100. All right, so I'm going to move on from there. Now I'm going to try to break down 50 into its smallest parts. Again, I'm going to start with 2. Is there 2 times a number that gives me 50? Yes, because I know 25 plus 25, or 2 times 25, is 50. So 2 times 25 is 50. Now I'm focused on the 25. Are there, will 2 go into 25? No. Will 3 be divided into 25? No. Is there a number times 3 that gives me 25? No. What about 4? No. 5? Yeah. 25 divided by 5 is 5. Or another way to look at that is 5 times 5 equals 25. So I've broken down the 100 into its smallest parts. 2 times 2 times 5 times 5. I have them circled here. 2 times 2 is 4. 4 times 5 is 20. And 20 times 5 is 100. So I'm hoping you can see that. If not, I got a few more examples. I'm going to break this down a little bit further. Okay, so I wanted to show you here. The square root of 100 is 2 times 2 times 5 times 5. We've just talked about that over here. Okay? And we always have that plus or minus or positive, negative on the outside of that square root value. Okay? So again, we're breaking down these radicals manually. In a moment, I'll show you how to also use your calculator in order to do this. So now, what do? I've got 2 times 2 times 5 times 5 inside the radical. What do I do now? Okay, now it takes 2 perfect pairs to pull out one value outside of the radical. So I have 2 2's. I can pull out 1 2 outside of the radical. I have 2 5's, perfect pair. I can pull out one value of 5 outside the radical. Then I multiply them. Everything on the outside, including the invisible 1, right, attached to the square root through multiplications. 2 times 5 is 10. 10 times 1 is 10. Now remember that plus or minus means or positive 10 or a negative 10. Both values, and I'm going to explain why later. This video's got a little bit long, but I'm going to explain in detail in the coming examples. Again, I go very, very slow. Do not like to speed through this. All right. And so in a square root, you need 2 perfect pairs. If this was a cubed root, 3, you need 3 of the exact same thing just to pull one out. If this was a fourth root, then you need 4 of the exact same things just to pull out one value. So this concludes part 4 video. Stick around for part 5. I'm going to do more manual simplifying of these radicals. I'm going to show you how to use the calculator. Math's easy. Take it step by step. Thank you for joining me.